Hello, welcome to another episode of Phi Mapping. Today we're going to look at this snail right here. So, interesting form, that is for sure. Tried and true. Not sure where the photograph came from, but it's a pretty good one. Square snail, not so square on the shell. These are the maps we're going to use. These are the shapes which extrapolate into these maps. They come from these two different types, Phi and Fibonacci. One is a sort of enclosure spiral, and one is a linear trajectory. So, let's try and just get a sense, see if we can find, let's just start with a square phi spiral map, and just to see if we can find a basic phi rectangle. So that's usually a nice place to start, is when we can find a perfect phi rectangle. So I'm going to just go ahead and assume the snail's in a pretty relaxed natural position. It's not stretching too much or anything, because it can obviously be anywhere in this space. So we're going to assume it's at a natural state there, which is suggesting that that is not phi. So from the bottom to the top does not equal the length. And however, it does equal almost the height to the back of the tail. And then if we take another one and we reduce it by phi, so 61.8%, that's going to give us this one, which is that. So there we go. So the snail is roughly 2 phi rectangles, phi of each other, scaled to each other. So, okay, that's interesting. So that one is the phi dimension of that. Rotate it down lengthwise, same way, and it goes right to the top of the head there. And then, indeed, if there is one more even, again reduced by phi, such that that equals that. And it does not really say anything. Okay, so, and then is there obvious rectangles in there? Notice that the body of this snail seems about that width, which off of this one is approximately this bottom. So if this is a phi rectangle, then that's a square, and that is a phi rectangle. And the snail's body is about that width, obviously. And if we do it just like this, see, the shell is, but look at that, there's a little spiral right there that, you know, certainly isn't lining up everywhere, but is pretty close to there. Okay, so the obvious thing, the snail shell and the famous nautilus shell, is that it's going to be a phi spiral. So let's just double check that right off the bat. See if we can find that phi spiral. And what we're going to learn is that, like the nautilus shell, it is not actually a phi spiral perfectly in that traditional sense. So if we go to the width of that shell, it's getting the shape, like elements of the shape. That's just because it's curved. And if we rotate it a bit, we're going to find that that spiral is never going to end up right there. Now there's definitely some 2D on 3D stuff happening here, plus that shell is out of perspective, but I bet you it's not actually a phi spiral. It's some kind of Fibonacci spiral, but There is squares in there. Let's try, instead of the rectangles, let's just try the squares and see if they can give us a little more information here. So the shell to the body is not even quite square. Interesting. So if we go perfectly square, if we go to that part of the spiral, so if we say that's square, then this one does not equal that either. Okay. So that shell is, we're going to have to investigate the shell specifically at some future point. We'll get a nice square picture of a shell. So if that's not square, let's try the circles for a second here, just to see if we can find any clear shape. It's going to be one rectangle high and one rectangle long. There's getting pretty close. Also understand that, again, 2D on 3D, that the bottom of this snail here is in fact a perspective thing coming towards us. I'd say the floor is just a little bit under there, which puts it like right back there. So this circle is extending into the floor. But that shell is pretty round. And if that's our scale, so we've got 4 different phi scaled circles here, all relative to each other. And take that one there, that one there, about as wide as the tail. That's, again, iterating that phi rectangle relationship in a different way. That's 3 consecutive phi right there. And the eye extending just beyond that, or that down there a little bit. Now if we took all of those and shrunk them, we can see that the main ones here are, see the tail extends about that far, it's about that big, and about that big. That also, see, that's going pretty close to where that eye goes into the body. And of course that eye's in a very arbitrary place there. They can move that all over. But that also, so see that part below the eye. And something like that. But can we make those circles do the shell? It's a spiral, so it's not going to be just circles, but parts of the circles will line up. And when we do that, can see, maybe that's the perspective part, but we've got, looks to me like it's this part of the line there. So if we put that right about on there, I mean there's a number of spirals in here. Yeah. And no, that was better before. They all hinge off the same point, but that doesn't really work for this one. Really throws this one off. Again, 2D on 3D. But, so, that I would say is predominantly how this snail is phi. It's a bunch of phi squares or circles together, stretched out in different ways. Now let's try a map here. Let's try a basic, go with the classic phi map. This is the phi spiral. And it does a great deal of curvature, so can be helpful for finding curves sometimes. So, on that notion, this is going to be similar to our square map, so there should be a little phi spiral right there. But since we know that's not ever going to actually fit, and yet that fits so perfectly like that, now, if there was other harmonies, but there's not really, is there? Okay. Well, if we go back to here and do that first relationship that we discovered there, then we might find these curves helping something. So those are the eyes. I'm not sure what these are, some kind of ground feeler, but they're coming right out of that spiral. The eyes are coming right in this phi mark. But that's relatively arbitrary placement relative to the scale. That's just more connected to this one, which is in fact deeper into the ground than it should be. If we reduce those to the actual ground, we're going to get something like that. So in this scenario, that's allowing, it's a little bit shorter than the body. It's putting that spiral right on this phi line, and it's showing this shell beautifully. Or the front part of this shell beautifully anyway. Get rid of that one, that's just for reference. And then it's also kind of going to do the back shell, so, and when it does the back of the shell, what does it also mark? It's also kind of marking that line, but really putting the rest of the stuff off. Okay. It's not completely obvious. I can see that's going to take a little while to jump out there. Let's try just the circle map. That might tell us something different. So the top of the snail. Now let's just go the whole length of the snail, just for, I mean, you know what? Let's just do it. If we go to the actual ground, should be roughly like that. So that again is hinting, see there's a circle in there that's not fitting exactly right, but if we wanted that circle to fit fully, we Might have to expand this even more. And when we do it this way, even a little bit more, so that that circle matches that shell quite well. And in point of fact, it almost wants to put that X right on the spiral mark there. You can see that circle is marking that shell moderately well, then loses it at the bottom. And isn't doing a whole lot on the rest of the body there. Well, if we try the other circle map, this being of the Fibonacci line nature, possibly because the shell is very circular, it's going to fit these circle patterns. Often the trick is whether or not you can get other things to fit. So align that to the top of the shell. It's putting the spiral right in that vesica right there. I mean, it's hitting other points, but it's also extending fairly well beyond the tail there, and is way below the line. So let's go back up actually to no, I don't like that one. Okay. There's a bunch of spiral maps, so let's try this inverted phi spiral, because that phi spiral works, so theoretically the inverse should work also. If we go right to the base, back to there, see this front line here goes on the shell very well. That's a very good descriptor of the shell. And the points here are certainly marking those distances a little bit. They're not exactly marking the outer shell. If we, let's go to the smallest one there. Yeah, that's marking those points really well. It's marking that curve, but there to there, there to there, it's very good. Yeah, you can see those three lines are marking this shelf quite well. It's not the same curve, but it's marking the curve points very well, I would say. Interesting. Go to the top of the shell, tighten it a bit. Again, that's doing that curve. Yeah, sort of, not quite though. That other one was better. So in certain ways this shell is phi. I mean, look at that right there. You go right on the halfway point of the shell, you get that line and that line. It's marking that curve, and you move it back up. marking that point, and that point. But the problem is it's not, and there it's marking that point, that's the outside of the shell. Oh, that's so close. How does, okay, what are we doing here? What if we go to the whole snail? The whole escargot. And we look for those same types of patterns. Wants to go even bigger. But now it's too big. But if we go right through there, it is kind of marking those key points of the shell. But it's too big. Yeah, it's too big. Okay, if we go down to there again, take another one and reduce it down by 61.8%. This is such a weird map. Because the other thing that it wants to do is line up with this discoloration on the shell, but I cannot quite see. Yeah, this map, so the inverse map of the phi spiral, kind of the finger shape, the closed finger shape, or the wrapped finger shape, fleshy part of your finger, is definitely connected to this snail shell somehow. There it's, but I cannot quite tell exactly how. Yeah, I mean, all these lines are doing almost, I mean, they're not quite, but okay, let's actually try this just with some core shapes here. For example, if we try this pattern, which is like the phi spiral, except it's bisecting, instead of squares, it's bisecting rectangles. It's going to be a bit of a phi measuring stick. So from this we could say almost the height of the shell there, but not quite. So that wants to be like that. Putting that too far, putting this too low. I mean, it's not really profound unless it all really makes sense. There is something here. What is it? Okay. feels like the fact that it does that shell and then does the absolute front of the snail is interesting. And at that same scale, so this is the same scale, just really talking about the eye. Is it? Oh, maybe, is that it? Yeah, because that eye is totally arbitrary. Yeah, it's doing the front well, but it's just not. The same as that. If we try this one here. So that's about to the ground, about to the top of the shell. Fit in like that. Yeah. Well, there's one. It's kind of talking about the width of that, of this one, and then this one and this one are talking about the width of that. A little bit. If we go full scale, top of that right to the floor. Yeah, again, that's going to show that relationship between the head and the body. And the reverse of that. Yeah, it would have to be from there, which is just marking where that curve goes. Nothing to do with the front. It's arbitrary. Marks right where the eye comes out to the bottom. If we do the inverse of the same scale, and put it close to the tail there. Yeah. Because the body of the snail itself is phi. So, actually, yeah, that's basically the same pattern, but in a different way. Let's go. The top of this curve is really, really harsh turn there, so it's not fitting the shape of that shell. But as a measuring tool, okay, all right. Yeah, how does that go? How does that go? I think that's mainly it. I think that's mainly it. I think it's, I think we're going to have to investigate the shell itself at some point, because the snail is not overly complex. It is phi in certain ways, and not always. And it is not as easy to find the particular dimensions that work perfectly. Let's try two more things here. No. Try these. Try this line. This is a major, this is like the opposite of the phi spiral. This is the Fibonacci linear. It can be a very good one sometimes. There it's marking a few points. Seems to be from there to the top of the shell, to the bottom of the body, to the next part of the shell, to the bottom of the body. Then it seems to lose it a bit. Then it seems to lose it a bit, eh? Take that one, reduce it down by 61.8%. Get it happening from the opposite direction. It's trying to do similar things with marking sort of the base of the tail, not the end of the tail, just the part of the tail outside there. But yeah, I mean, how this map marks that little feeler. If we go right to the ground almost, it's going to want to basically be like that, so it's a little deceptive because of that flange. It depends where the actual ground is there in terms of height. And all information is relevant. Yeah, that's a pretty good one. Yep, that's definitely part of it. Marking the back behind the eye there. And that one the other way from the tail. Yeah, kind of marking the end of the tail. Yeah, little bits, right? So to see that in the actual official map form, and if we go to the whole creature, possibly wants to do that, so it goes from that bottom point to the top of the shell, and then from there to the tail. Interesting that it's really marking a halfway point, which is not at the top of the shell. That's not in the center. Yeah. That wouldn't be too comfortable doing it much smaller. Yeah, you could argue it's that one. I feel like this line here is right. Just because how it goes behind the eye, it hits right on that, then shoots back and talks about the shell. The rest of it isn't really doing a whole lot. Let's just do that like our first map, where we go from there to there. Or actually, yeah, let's do this. But we'll shrink that one 61.8%. Yeah. Make sure that's the same length. This is supposed to be tracking the whole body. So we will fudge it a little bit here. Don't want to overshoot the height too much. Oh, we're doing a chaser game where that angle, I'm going to no matter how big I get it, I'm going to have to keep pushing it that way, and it's never going to meet the end. But if we find the right spot there where it hits the shell, hits that, and goes to the end, it's right about there. That's marking that point where that eye comes out. It's marking this height. Feels like that's a little above the ground though. Just about where the spiral's coming. Again, points to the top of the shell, but doesn't do anything spirally. It doesn't do any other shell curvature. That's all right. Yeah. Okay. Yep. Yes. Yeah. Okay. I think that's it. Thank you very much for joining us on this particular episode. It's kind of a neat one. We're trying to investigate the phi relationships within this snail here, of which there certainly were a few, and some that I couldn't quite find. Hey, there's another one. See, yeah. So this one's kind of arbitrary. It's not really talking about a lot, unless it's out here. This one's definitely talking about the height of the body. And if that was talking about the height, then it would hit right in the eye, right to the sensory part. This is the height of the tail, or the width, or whatever is on the tail there. Yeah, okay. Well, there's definitely phi in the snail, that is for absolute sure. But I could not exactly find the exact shape. So we're going to have to defer that, and we will come back to it, see if we can look at some other animals and get some more clues. Thank you very much, guys. Hope you have a great day out there. We'll see you on the next one. Take care.